lesson 3.3, data analysis and conclusions. We're going to be talking about center and variability and what they can inform us about in a data set. Let's get going. So where's the middle? Where's the middle of a data set? These are measures of center. Measures of center are a statistical measure that show where the middle of the data set are. Some of these may be familiar to you. They might include things like the average, and by average we mean the mean. That's the more mathematical term there. We might also be talking about the median, and the median is the middle number in a data set, or even the mode. The mode is the most common number in a data set, and we'll talk about how to find these using a spreadsheet. Another thing we're going to be looking at is kind of how consistent the data is. I'm not sure if consistent is a perfect word for talking about variability, but if I think about a set of data, are they like really spread out? Are they really close together? If they're close together, very similar, it sounds like something is happening in a very consistent way. These are measures of variability. How spread out are the values in the data set? So these would include things as simple as the range, and the range is the largest value minus the smallest value. Another is the interquartile range. Quartile range. And we'll talk about how to calculate that, and as we calculate that, we'll talk about exactly what it means. And the last one we're going to talk about is mean absolute deviation. And sometimes that's abbreviated as MAD. Mean absolute deviation, we'll walk through those calculations too, but to give you a big picture, this is talking about if you compared like a set of data to its average, so the individual pieces of data to the average, how close are they? Are they pretty close to the average, or are they pretty spread out from the average? And that can tell us, again, how consistent, how spread out are the data values. So now that we've talked about measures of center and measures of variability, let's go ahead and look at an Excel spreadsheet or a Google Sheet and talk about how to find these measures and calculate them. Okay, so here we have the data that we're going to be analyzing. This is data from the NBA 2020-2021 season, and this is game logs for 4 different players. So if you look at the bottom, we've got some tabs, and right now we're on the Steph Curry tab, and that's where we're going to spend most of our time today. We will be using most of the other tabs in part 2 of our exploration of this NBA data. Okay, so this is every game that Steph Curry played last year, the 2020-2021 season, and we can see things like how many minutes he played, how many rebounds, assists, blocks, and even points that he had for that season. Okay, for each game. So what we want to do is start to analyze this data. And yes, this data did come from ESPN. All right, we're going to go down to the bottom. So one thing that we're going to do is we're going to find the totals of these data values. So I'm going to label this row totals. I'm going to come over here. So here's where we're going to want to enter our formula to find the totals. Now that formula is actually the sum formula. So I'll type equals SUM, open my parenthesis, and now I'm going to click and drag all the way up. I think I need to zoom out to do this. Zoom out. All right, so if I click and drag all the way up to the top, and then I can close my parenthesis and hit enter. Terrific. Total number of minutes played last season was 2,174 for Steph Curry. So we want to drag this formula all the way across. We do that by getting the blue square at the bottom. When we go our mouse cursor over there, it turns into the crosshairs, and we can drag that right across. So now we found the totals for each of those rows. Terrific. The next thing that we're going to want to find is the median of this data. Median is the middle number. So I put my median over there, and while I'm at it, I kind of don't like how those are way over there. I don't really need anything to fill in these other cells, so I'm going to select these cells here. Now, I don't want to merge all of them together. I just want to merge totals with the ones to its right and median with the ones to its right. If you go up to your merge selection arrow here, One of them is merge horizontally, and that's what we want to do. It merged across. And while we're at it, let's go ahead and I'm going to right justify it so those are nearest to the numbers I'm using. Okay, to find median, we're going to use a new formula. It is median. I love when the formulas are the same as what they're doing. No complicated syntax there. All right, so, and we just select all of the data points, close our parentheses, and hit enter. So the median, the middle data value for how many minutes was 35. Well, let's drag that across and we'll get the median for all the other types of data. So even points, the middle number of points Steph Curry scored was 32. Okay, let's keep going and add a few more pieces like the average, which I'm going to put in parentheses here, is the mean. That's the more mathematical term for it there. And our formula here is average. We've done this one before. So we type average, open a parenthesis, and we can drag and highlight all of these. Terrific. Well, before I drag that across, I'm going to go ahead and find one more type of data point, and that's going to be the mode. And I'll show you why I didn't drag that across yet. If I go here and I type equals, well, the nice formula for mode is mode, open our parentheses, and then we drag and select all those data, close our parentheses, enter. Well, now we've got two formulas that we really want to go all the way across. If I highlight both of them, now if I drag this across, it moved those formulas for both of them. So it saved me a little bit of time instead of dragging each of them individually. Okay, so we've got mean, average, or mean, median, and mode. All of these data types, I'm going to kind of label these. Over here, I'm going to merge these cells. These are measures of center. So I merged those cells. I'm also going to center it. That's centering it horizontally. This is centering it vertically. And let's make it bigger. Let's make it size 14. That's beautiful. All right, let's add let's go ahead and fix these up here. Let's go ahead and merge these across as we did earlier. Merge horizontally. We'll right justify that. And I'm going to even add some fun color here. Beautiful. Look at that. Now, some of these data points, we can see like the decimal is going off beyond what we can see, and it's not even fitting in that cell. We could make the cells bigger, but really we probably just don't need to see it that specific. So for this average row here, I'm going to highlight that row of data where the decimal is going too far. And if we come up here, below the word format and data are these decimal points, and there's arrows, and we can see the 1 is decreasing decimal places. So if we keep clicking that, we can see it's reducing the number of decimal points. We'll go down to just 2 decimal places for that, and that's really pretty helpful for us. We don't really need much more there. Okay, so those are our measures of center. We also want to look at some measures of variability. So one measure of variability is the range. Now, unfortunately, Sheets doesn't have one formula that can do range for us. But we're going to get some extra important information as we go ahead to figure that out. What we can do is we can find the minimum. So minimum is a nice formula. It's min. We open our parenthesis and we can select all of our data. Great. Close our parenthesis, enter. All right. We also want to find the maximum. Well, we can type our equals, and again, it's nice, it's max. Open our parentheses, and we can select all of these. Terrific. Well, if that's the min and that's the max, our range is the difference between the min and the max. So this formula is going to be interesting. We're going to click equals, and then we want to take this one, which is the maximum, and notice when we clicked on it, it put that cell number there, minus the minimum. So those two, if we subtract them, we will get the range. And it's already kind of showing us the calculation. In this case, it's going to be 20. If we hit enter, there it is for us. Terrific. All right, so we found the range. That's one measure of variability, but there are others. The next one we want to find is the interquartile range. Again, there's not one formula for interquartile range. The interquartile range is finding the differences between the third quartile and the first quartile numbers, basically where 25% of the data is up to the 75th percentile of data. That's the middle 50%. Okay, so the first quartile is often called the lower quartile, so I'm just going to label this lower quartile. Perhaps one of the trickier formulas that we're going to type in here. Okay, so in this square, we're going to start with equals quartile. Open our parenthesis. Okay, and now I'm going to select all of the data points that we want. Great. Now we're not ready to finish this one up yet. So what we need to do here, after this, is we need to put a comma. And because it's the first quartile we want, we're going to hit the number 1. Now close our parenthesis, enter. Okay, we got a number. What did it mean? It means that in terms of minutes that Steph Curry played, 30.75. There's 25% of his games he played less than this. 75% he played more. It's the first quartile. So 25 below, 75% more. So this is kind of on the low end of his games that he played. Well, we also want to find the upper quartile. It's very similar. We're going to type equals quartile, open our parenthesis. We're going to select all of the cells that we want. We're going to put a comma, but then since it's 3/4 of the way across our data, we're going to put a 3. And you're like, why not 2? What would happen if we put 2? Well, 2 is the middle of the data, the second quarter. The second quarter is the same as the half. The halfway point of the data is the median, and we already have that. So now we found the third quartile. We put a 3, we put enter. So 37 minutes for Steph Curry is 75% of the data of the time he played 37 minutes or less. 25% of the time he played more than 37 minutes. So these two numbers are what help us find the interquartile range. So to find the interquartile range, this is going to be pretty similar to the way we found the regular range. We need to click the higher quartile minus the lower quartile, the upper quartile minus the lower quartile. And we click enter, and there we go. And so for Steph Curry, 6.25. That means 50%, the middle 50% of his games, he played within 6 minutes of the same amount each time. So that's a helpful number. Okay. There is one more type of calculation that we are going to want to find, and that's the mean absolute deviation. Now, for this data, it would take a lot of time to do this for every piece of data, like minutes, rebounds, assists, all the way over to points. So we're only going to do this for the points. But let's do a couple of things first. I have all of these data titles. I'm going to highlight them, and now I'm going to merge horizontally, and I'm going to right align. I'm going to take all of these formulas that we have. I highlighted them all. Clicking the blue square, I'm going to drag them all across. All right. A few other things I'm going to do. I have several cells down here that are measuring variability. So I'm going to merge these cells, and I'm going to label these as measures of variability. I'm going to center that horizontally, center that vertically. Let's make it size 14. Now, not every one of these is really a measure of variability. This row is the range, the interquartile range is, and so will the mean absolute deviation. So I'm highlighting those. I'm going to make those. Let's go ahead with a nice light purple color here, and I'll make this that same color, light purple, whatever color makes you happy. Okay, so we have a couple of measures of center, a couple of measures of variability. We need one more type of measure of variability, and that's the mean absolute deviation. The big idea behind mean absolute deviation is if we look at any one of the data points, so any one of Steph Curry's games, how much different was he than his average, than his mean? each game, how different from the mean. How different, we're going to call the deviation. So we want to know how much different each game was than his average. Okay. Right next to his data here. So I'm going to start right here in this bottom cell. So he scored 20 points on the last game of the season. Right over here, I'm going to click equals. And I'm going to take this score he had, 20, and I'm going to subtract his average right here. Okay, that'll tell me how different he was from his average. So he was way below his average this time. He was almost 12 points below his average. Okay, that's interesting. So you're like, well, what about the game before? I'm going to show you something that's a little bit wrong. So if you want to just watch for a second and then follow me, you can. So if I go ahead and drag this formula up, oh, is he 13 points off? Was that worse? Okay. And what happens if I drag it up a couple more? What? 2,000 points off his average? That can't possibly be right. We're getting something that doesn't make sense. So let's open up this cell a little bit closer. So it's telling us what numbers it's subtracting. It's taking K63, which is this 36 points, and it's subtracting this number 2,043. Well, that's his total points for the whole season. That's why we got such a small number. We don't want to subtract his total points for the whole season. We wanted to subtract his average. So what we can see is happening is that each time we drag the cell up, yes, the orange box kind of moved up. So down here, see the orange box is here, orange box is here, orange box is here, orange box is there. The orange box is moving up, but look, the purple box is moving up too. We don't want the purple box to move up. There's a way to fix that. The purple box, we want to keep it in row 69. So to do that, right here, between the K and the 69, we're going to put a dollar sign. Why a dollar sign? I don't know how they came up with that decision, but if we put a dollar sign in there, it won't let the formula change that row number. Okay, I'm going to hit enter. And you're like, well, those other numbers are still wrong. Well, if you change one cell, it didn't change it in the other ones. But now we can drag back over. Oh, these numbers make much more sense. And let's just do some quick checking. Up here, 31, yeah, that's really close to 31.92. If we double click it, we can see the orange cells up here, the purple's still down there at the average. Here, orange, it moved up, purple stayed the same. Orange, where it should be, purple in the same place. Great. Now, these are all the deviations. How much Steph Curry deviated or was off of his average. Well, we're going to do one more thing. Sometimes we don't really talk about, it's like he was negative 11 points off his average. Well, he was 11 points below his average, or maybe even 12 here. So we want to just make all of these positive, really, by taking the absolute value. So the formula for absolute value is ABS. So we do ABS parenthesis, and we click here. All it's going to do is turn that positive. The absolute value of negative 11.92 is positive 11.92. All right, so we've got formulas here and here. We did this once horizontally. Well, I'm going to select these both, and now I'm going to drag them vertically all the way up to the top and stop right there. Good, I did stop one before the top. So I might want to label these. This column is our deviations. This column is our absolute deviations. Great. All right, so let's zoom back out. So we're getting close to being able to calculate the mean absolute deviation. So we come back here. We're only going to do this for points because we'd have to do these columns for any one of these. These columns are all about points, the deviations and absolute deviations. All right, so right here, we're going to put in a formula. So our formula for mean absolute deviation is it adds all the absolute deviations up, and it divides by how many data points there are. Well, how many data points are there? Before we do that, we need to figure out, before we calculate mean absolute deviation, we need to know how many data points there are. So let's go up here. We're going to make a little space here. I'm just going to say number of games. So we could count them all, but why count things when we have an impressive spreadsheet that can do it for us? So here's a little formula that can count the number of cells that contain something in them. So we're going to do equals. We're going to do count. It's going to count how many there are. Notice right here it said it counts the number of numeric values in a data set. So there are other kinds. There's like, I think it's count A for counting how many cells contain words or text in them. So this is counting for how many have a number in them. So we typed count, and then we'll highlight all of these, not our title, close our parentheses, hit enter. Steph Curry played 64 games. Let me just kind of make that a little prettier here. All right, great. So 64 games. So now we have everything we need for mean absolute deviation. All right, I'm going to zoom in here. So it's equal to the sum of all the deviations. So we select this column. Go for me. It's going to make me zoom out again. All right, zoom and up again. All right, we are going to close the parentheses because that's the end of the sum. But we're not going to finish our formula yet. We're going to divide. How do we divide? To divide, we are just going to use the slash, the backslash specifically. And then, what are we going to divide it by? How many games he played? 64. So that's our formula for mean absolute deviation. We hit enter, and we get this number. And let me just show you that formula again a little closely. We have the sum of that column of deviations, and we're dividing by, there's the backslash, M67, which is the number of games. The number we got is 7.8. It's important to understand what that number means. That number means that on average, the average game for Steph Curry, he was, if we rounded this to 8, he's about 8 points away from his mean on average. So within any game, you should expect Steph Curry to be 8 points above his average, which is around 32. So he might be up to 40 or down to 24. So that's around where Steph Curry's point totals were typically in this past, well, in the 2020-2021 season. Okay, so we have a lot of great data here, and this data will help us to now compare him to other players in tomorrow's lesson. So join us back tomorrow, and we'll use this to start to compare Steph Curry to some other players like LeBron James, Giannis, I wish I could pronounce his name, and Kevin Durant. So thanks for joining us, and we'll see you again next time.